Good morning, viewers. I really hoped I would never have to make this intro. We work really hard to follow the rules of YouTube and the rules of monetization. Before you is a screenshot of what Google says will get you demonetized. Well, we have a slight problem. We've had 2 of our videos in the last few weeks demonetized. YouTube won't give us any good answers to why, as well as no feedback. So we come to you to ask you for help. Here are the reasons why YouTube says they'll demonetize a video, or could demonetize a video. Well, here is a view of our studio, and you can see the 2 videos marked with the yellow limited icon that we've been demonetized on. They're both related to LXC or LXD. We've checked and even used Google's closed captioning service to verify that Google does in fact understand that we are saying LXD or LXC and not something more drug related. So, if you at all during your viewership of this video or any other video see anything that may raise a red flag to something that we may be doing, please comment below and let us know. This will continue to help us grow our channel, make profit, so that we can bring you better and more informative videos. This money goes towards purchasing new gear, and that's it. So I can bring you more content on different things revolving around virtualization. Also, I believe that I may be making some more videos, a tad more outside virtualization. We'll still be using virtualization and containers and other things that we set up, but we might start to wrap in some Home Assistant or other things that are done inside a virtualization container just to continue to bring you timely and informative content. If you think this is a bad move or you support this move, drop a comment. With that, let's move on to the regularly scheduled video. Welcome to Virtualize Everything, where we strive to educate and inform the viewer about technology and technology-related topics around the world of virtualization. So tonight's video presentation is going to look very similar to one we've done in the past, with installing LXC. But here's some background. This presentation is going to be a little bit different, as we're going to be doing it on a Raspberry Pi. Not only are we doing this on a Raspberry Pi, but we're doing this in a way that we'll be able to create a really nice low-powered server for home lab uses later on. So, with that, we're going to get to the presentation. Now, I'm going to insert a clip right here about how I got Raspberry and OS 64-bit version onto this Raspberry Pi 3. That's right, we're going to use a Raspberry Pi 3 today, not the newer Raspberry Pi 4, although you can follow all of these steps on a Raspberry Pi 4. With the chip shortage, I thought it would be nice to use some older tech and show that it still can be used for various different projects, like this one. So, with that, watch this clip, and in a second, you'll be back to this tutorial. For this project, we're going to be using the 64-bit version of Raspberry Pi OS. To install this OS can be a little bit complicated from time to time, so I thought I would add a little bit about how I go about getting it to this video. So here we go. Let's look at why this is so complicated. I have Raspberry Pi Imager already installed on my system. You can get this from the Raspberry Pi website. If you need help doing this, check out some of the other videos on YouTube. Alright, so if we click Choose OS and pick the Raspberry Pi OS, you'll see that we have no 64-bit options. Now, if you scroll through some of these others, you'll find there's also no 64-bit option for Raspberry Pi OS. So how do we get it and how do we use it? Well, the way I go about getting it is to do a search for Raspberry Pi OS 64-bit edition. My search results will come up looking something like this, And usually in the top 1 or 2 will be the website piemylifeup.com. This is the website I traditionally use to get the link to download my 64-bit up-to-date version of Raspberry Pi OS. So here's the article that loads. And if we scroll down through this article, we'll find obtain the latest release of 64-bit Lite Edition. And it brings us here. Of course, we can select the most up-to-date version, click on it, and I select the zip so I can download this. Now, I already have it downloaded. It's right here. So now, using the Raspberry Pi Imager tool, I select Choose OS, then I select Use Custom, and now, looking at my desktop, I can select the newly downloaded version of the ARM 64-bit version of Raspberry Pi OS. Then I just click Open, and it's ready to be loaded. So then I can just select my storage device and press Write, just like you would every other time. Now, as a note, you may also find that you want to add SSH to your install to do something headless. For the rest of this tutorial, you'll see me using SSH. To do that, as we're going to cut back to our main video, you just add a file, a blank file. I usually create it with Atom, called SSH, not .txt or anything, just SSH. That enables SSH for use when you fire up your Raspberry Pi for the first time. Okay, so now that we've learned how to install the 64-bit version of Raspberry Pi OS using the Raspberry Pi Imager tool, and we've loaded into our Raspberry Pi, configured our password, and expanded our storage on the Raspberry Pi. If you don't know how to do these steps, watch some of the various other Raspberry Pi videos on YouTube. There's a lot. We're going to now look at setting up a static IP address for our Raspberry Pi. The reason we're doing this, as a home lab server, our Raspberry Pi needs to have an identifiable address, so later we can log into it and use it. We don't want it bouncing all over our network. To do this, we're going to use the command sudo nano etc dhcp cd.conf. And you get a configuration file that looks like such. Now the lines we're looking for are already in here. They've just been commented out. So we can use the down arrow to scroll through this file and look for the lines. So here's the lines for configuring a static IP address. We want to enable the interface ETH0, as this is a server and we're going to be connecting it to Ethernet. With this tutorial, I highly suggest you use Ethernet and not Wi-Fi because of the limitations of how Wi-Fi routers work with IP addresses and the intended purpose of this server configuration to make its containers easily accessible via IP addresses housed within your network. You could configure a NAT setup or even use a proxy style setup with a bridge. LXC supports all of this, but it's harder to work with. So today we're going to show you how to configure LXC or LXD to be used in an easy manner on your Raspberry Pi. So Ethernet it is, ETH0. Now we want to decomment this line and configure our IP address. And I'm going to place this server at 200. I don't want IPv6. If you do and you understand it, you can uncomment that line and configure it. Static router, I need to configure. And static domain name server, I can configure. We can delete the IPv6 address at the end here, as well as Google and whatever private IP address this is by default. We don't need that. And for the sake of this tutorial, let's configure Cloudflare. Okay, with all of this done, we can press Ctrl X to save, Y, yes, enter, and now we can reboot the Raspberry Pi. After entering this command, your SSH session's going to close out, and we're going to have to reestablish it at the new address. Alright, so our Raspberry Pi should be up and running at this point. So we can enter our newly configured IP address and press enter. If you're not using PuTTY because you're not on a Windows machine, please follow your system steps for SSHing. We can log back in. Okay, so let's get with installing LXD on our Raspberry Pi. The first thing we want to do is to run the command sudo apt update. This will update our repositories. Okay, so now we need to install the Snap Store onto our Raspberry Pi. We can do this with the command sudo apt install snapd. We can add a -y at the end so we don't get asked that yes or no question. So now we can use the command sudo snap install lxd channel equals latest / stable. This will install the newest stable version of LXD housed on the Snap Store. Alright, so now LXD is installed on our Raspberry Pi, and we can begin working with it. So, one of the first things we need to do is configure LXD on our Raspberry Pi for its configuration on this system. Unlike our previous video, we're actually going to use non-standard settings. This is going to allow us to have our system use the same IP address as all of our other systems on our network. This will allow us to more easily interact with our systems that we create or containers that we create on our network, more or less like we would when using Proxmox. So to do this, we're going to enter a kind of odd sudo command, sudo-i. If you don't use sudo-i, you're actually going to get a weird message that looks like this. That you actually can't find the command. So if you're wondering what sudo-i does, we can actually run the sudo-h, which is help, and scroll up through this window. And if we look around, there it is. -i runs login shell as target user. So it's kind of cryptic, but it makes LXD and LXC commands all work on your system. LXD in this case, and init or init. This will start the configuration process of your new LXC or LXD server. Alright, so our first question. Would you like to use LXD clustering? We're going to choose no today. But no, in future videos, we are going to set up a cluster. This kind of gets really fun, especially when using some low-end tech like Raspberry Pi 3s. But more on that later. So now, would you like to configure a new storage pool? Yes, I would. The name, we're going to use default. Now, you can choose whichever style storage pool you want to work with. But I'm going to choose dir or directory. Now, there's some pros and cons to all of these, and my comments box may fill up with some of them from some of you that have your own preferences and understand. I'm going to use dir because I find it the easiest, and it just sizes itself to what my drive looks like. This is my own personal feelings, and it works for me. There may be reasons to use an LVM, CFS, ButterFS, or even Ceph. I haven't run into any that I really particularly felt that I needed. I've read by them, and if you feel I'm wrong, or maybe want to teach me something, feel free to comment. Go right ahead, I love the information. So, DIR it is today. A MASS server, we're going to choose the default of no. Would you like to create a new local network bridge? The default is yes, and by default, LXD or LXC will create a bridge. But when we create that bridge, LXD actually sets up its own DHCP server and IP range and isolates all of its containers behind a proxy. This makes it very hard to interact with them from our local network and even set up things like Pi-hole or file servers, even a VPN server, as we very well might want to do as part of our home lab server. So let's choose no. Would you like to configure an LXD using an existing bridge or host interface? The default is no, but we're going to choose yes. Now it wants us to enter the interface. In our case, with this system, and most Raspberry Pis that I've interacted with, all Raspberry Pis I've interacted with, it's ETH0. Would you like LXD to be available over the network? The default's no, but in some of these other videos, we're going to establish a container that actually interacts as a web interface for basic management of our LXC server. So we're actually going to choose yes. Address, all. Default port of 844.3 is fine. And we need to establish a trust password. Would you like to update images automatically? Yes, that's fine. Would you like a YAML file output of the LXD init? No, I don't need one. Alright, so LXD is up and running. So now we can actually view the containers that are established on our LXC server by using the command sudo -i, and this time we're going to enter LXC, not LXD, and list. And you'll see we have no containers. So for the sake of this tutorial and getting you started, I'm going to show you how to download your first container and how to log into that container. In subsequent videos, we're going to set up a Pi-hole server, OpenVPN server, a Nextcloud server, and even a Samba server. Maybe I'll also make a container that runs Docker. You don't have to run Docker inside of a container on a Raspberry Pi. You can run it natively. But I like containers. And then maybe we'll use that container for Home Assistance. We'll see where we get in future videos and how popular these videos end up being. Our last installing LXC or LXD video wasn't super popular. So we'll see. We'll see how this goes. So, with that, let's create our first Ubuntu container on our new server. So, let's use the command sudo -i again, and we'll enter LXC launch Ubuntu, and we're going to ask it for 2104, and the last part is we're going to give this container a name of Pi-hole. So pressing enter will start the download of the container. Alright, so our container should now be created. If we want to view that our container is working and created successfully, we can rerun the command sudo -i LXC list. But now, instead of seeing nothing, we should actually see our container. And you can see our container and that our container's been configured on our network address. If you remember from setting up our static IP address, our network is the 10.10.2.x or .255 range. So, one last thing I want to go over with this video before we conclude it, and that's actually how to interact with this container we created, so that you could begin configuring it to be Pi-hole. We're going to cover that in another video, but maybe you want to create a web server or something that I'm not going to cover in a video. It's good to know how to do this. So, the command to do that, again, is going to be sudo -i, and it's going to be lxc exec, the name of the container, in my case it's Pi-hole, bash. Oh, I see what I did wrong. Now, as you can see, our command prompt has changed to root at Pi-hole. We've logged into the container. So if I wanted to just run like an apt update to show you that we're in the container and it works, I can do so. So there you have it. As this updates, we'll conclude this video. So in this video, we installed LXD on a Raspberry Pi. I showed you where I got the 64-bit image that I'm using on the Raspberry Pi 3 for the operating system. And I showed you how to set up LXD to be configured to work on your actual home network without a bridge or any other instances. This will allow you to more easily work with the containers that you set up on your home lab server in the future. So with that, if you enjoyed tonight's video, found it educational, or would like to support Virtualize Everything, please like, share, and subscribe. Also consider checking out Virtualize Everything's web store at store.virtualizeeverything.com. Have a good night.